Hello, my friends. I hope you're having a wonderful week. Today we're talking about method of sections. So grab yourself a piece of paper, a pen, a calculator, and even you can get your coffee. Coffee just makes things better. And let's go ahead and talk about method of sections. As always, I want to remind all of you with an engineering degree from outside of US that if you want to evaluate your education in this country, I have put together a PDF guide with step-by-step instructions on how to do that. Just click the link below and you'll be able to download it for free. Now let's go back to method of sections. The problem says the cantilever truss shown supports a vertical force of 6,000 newtons applied at point G. What is the force in member CF? Here is our member CF. When we're using a method of sections, we have to section our truss and go through the member we are asked to calculate. In this way, we will be able to do sum of moment in a few points, which will allow us to calculate the force we are asked to calculate. Now, I'm thinking we'll have to section our truss here, but the maximum members we are allowed to cut is 3, because we have only 3 equations of equilibrium. Now here I have 4 members, so I have to go back to my step number 1, which is identifying the zero force members. Always when you have truss and no matter what method you're using, either method of joints, method of sections, it's very useful to get rid of the zero force members. It will give you a more clean truss. So in this case, I'm looking at my node D, and these are 2 non-collinear members with no outside force, meaning in order for this point D to be in static equilibrium, these 2 members, they have to be zero force members. To learn more about how to identify the zero force members, I have put a video together, and I will leave a link below this video. So now that we have these 2 members 0, we will be able to make a cut in our truss, and we have only 3 members, which is exactly what we need, is maximum allowed. Another thing I want to point out, we don't need to, but we have another zero force member. Here we'll have a reaction in this direction, which is going to be collinear to this member, meaning that this right here, it's also a zero force member. Once we remove the zero force members, our truss will look like this. We will go ahead and do our cut here. Now, after you identify the zero force members, always I suggest the next step would be to calculate the reactions. In this case, once I do the cut, I'm noticing that this side of the truss doesn't have any reactions, and I will be working with this side. Just to avoid calculating the reactions, you obviously you can go ahead and calculate the reactions and use this side of the truss, but I'm choosing something that I feel more comfortable with. It seems easier to me, so I will be using this side, and this side doesn't have any reactions, so I can just skip calculating the reactions altogether. Remember that you only skip this if you have both reactions on the other side, because most of the time the truss has one reaction, one support here, and another support all the way here, in which case you will have to, once you have a reaction on your section, you have to calculate them. In this particular case, I will not. So once I do this cut, my truss will look like this. So now let's discuss another very important thing, which is we have to calculate the force in member CF. I have 2 other unknowns. I have force in member, let me add it here. force in member EF. I also have force in member EG. And we are asked to calculate the force in member CF. So we have three unknowns, and we have to find a point. And most of the time, you have to try and find a point to calculate the moment in that point, which will eliminate your other unknowns and will leave the force in the member that you have to calculate. In this case, I am noticing that that point for me is point E. If I do the sum of moments in point E equals 0, this will eliminate these two forces, which is wonderful because I will have an equation with my only unknown force, force CF. Let's go ahead and do that. Do sum of moment in sum of moments in point E, I believe, right? Yes. Sum of moments in point E equals 0, resulting. We'll have CF times 3. CF times 3 minus 6,000 newtons. Equals 0, resulting that force CF equals to 6,000 newtons. 3 meters equals 2,000 newtons. Now, sometimes it's not as easy to be able to find a point which will eliminate the other unknowns and leave you with only the member that you are asked to calculate the force in. I will try and put together another video showing you another more complex truss, but this one was a very easy fix. You didn't even have to calculate the reactions. You found a point in point E, which eliminated these two unknowns that I don't need to calculate, and it gave me a chance to find my force very, very easy. That was it for today, my friends. It was a very simple truss. It actually took me less time than I was expecting. I believe next week I will put together and find a truss, a more complex truss that will have or that will need more calculations to be done in order to find our force. Don't forget, if you have an engineering degree from outside of the United States and you want to evaluate your education in this country, I have put together a PDF guide with step-by-step instructions on how to do just that. Just click the link below and you'll be able to download it for free. If you found this video helpful, don't forget to subscribe and give it a like, because this helps people like you find me. Keep on practicing, my friends, and I will see you next week.